Hi, and welcome to 3.5, Overlapping Triangles. For homework and classwork, we're going to be working on page 139 to 141, number 2 through 12 evens. Okay, so now let's start talking about overlapping triangles. Overlapping triangles are triangles that are considered to have a reflexive side. Now, either they're reflexive like the way we like it, or there's another type of reflexive, and we've briefly discussed both of these types, what I like to refer to as the crown reflexive and the boomerang reflexive. When I look at triangle ADB and triangle ABC, they have an overlapping side. I'm going to pull them apart. When I look at them, both bottoms are segment AB. The full segment from A to B is shared, therefore it's reflexive. Next, we have an overlapping angle. Remember, angles don't stop where the triangles end because angles are created out of two rays with a common endpoint. Angle W is going to be our reflexive angle for triangle XWY and for triangle VWZ. When I pull it apart, you'll see not only do they both have that corner W, but when I have them on top of each other, we can see that those rays are going to be traced over. We have one ray and a second ray. Although they stop here for where the triangles end, we know that their rays for their angles will continue on. Alright, so now let's practice some proofs with overlapping triangles. So here we go. Let's start off with our statement and reasons. And let's start off by listing out those givens. So our first given, AE is congruent to KL, that's given, and KA is congruent to EL, that's also going to be given, and let's mark that up. We got AE, which is going to be this piece right here, is going to be congruent to segment KL, which is going to be this segment right here. Now, I don't know about you, but for me, when I'm talking about doing this stuff, I have a really rough go of it. I don't like drawing out my congruencies like that, especially if I don't have colors. So instead, what I'm going to do is I'm going to take those triangles and I'm going to pull them outside. So here we go. That first triangle that I have is triangle KAE, where my tick mark is going to be on that AE. And for my second triangle, I have LEK, where I have my tick mark on KL. Alright, here we go. My second set of tick marks that I have KA, putting my markings on both my original and on my new one, is going to end up being congruent to segment LE. Again, tick marks on my original and tick marks on my new one. Now, what I see down here is that both triangles have an overlapping bottom. The distance from K to E is exactly the same, therefore it's going to be reflexive. I'm going to say KE is congruent to KE. The reason? Reflexive. Put in my markings. Alright. Now, I'm going to look at my original figure, I'm going to look at my new figures, and I see that I have triangle congruency. I'm going to say the triangle KAE is going to be congruent to triangle ELK. Now, why did I order that way? Let's look at K, where K is located. K is located at the intersection of the 2 tick mark and the 3 tick mark, just like where E is located. They're corresponding parts. Now, my triangles are congruent by side, side, side. Last but not least, I want to prove why is angle A congruent to angle L, and when I look at those, they're corresponding pieces. They're both located between the 2 and the 1 tick mark. So let's go ahead and say that. Angle A is congruent to angle L. The reason is they're corresponding pieces of congruent triangles, which makes them congruent. Okay, here's our next proof. We're given that segment AE is congruent to segment AD, and segment AC is congruent to segment AB. We're trying to prove that CE is congruent to BD. Now, I want you to take a second, press pause, and think what we have. Let's see what we can do with the information that we know. Okay, so the triangles that we're going to be using, I went over in red and orange while we were stopping and thinking. Now, what we have here is we have a reflexive angle that we're going to be using. It's angle A. And we're going to want to name that with the 3 letters that belong to each set of our triangles. Now, here's the reason why I chose this one with a top reflexive angle instead of this bottom one with a reflexive side. In this triangle with the reflexive angle being this angle A, what I have here is I knew one big side AC matching with one big side AB, and I also knew the shorter sides. I knew that that AD shorter side was going to be congruent to the AE. So let's go ahead. I'm going to draw those triangles out to the side so we can kind of see what we're looking at here. So my orange triangle, I had A, E, and C. In my red triangle, I had A, B, and D. And let's list those statements and reasons. So for my statements and reasons, for my givens, I had AE was congruent to AD, and AC is congruent to AB. Both of those were given to me. And again, when they're overlapping, I kind of struggle to put down where my tick marks are. Now the AE one and the AD one, not so bad. The other ones, I kind of got to make these little swirly things for me, so I know what I'm talking about here. So instead, when I pull them apart, here's my AE, here's my AD, beautiful. My AC and my AB, looks wonderful, doesn't it? Alright, now we have that reflexive angle there. Remember, that's going to be a full angle, so I see that both sets of rays are overlapping. I can say on my orange triangle that angle CAE is congruent to, on my red triangle, angle DAB. The reason is it's reflexive. And I can put in my markings here. Which means that, of course, my triangles, triangle CAE is congruent to triangle BAD. Isn't that bad? By side angle side. Now, CE is a piece of my orange triangle, BD is a part of my red triangle, so let's go ahead and name that congruency. CE is congruent to BD. The reason? They're corresponding pieces of congruent triangles, which makes them congruent. So here's the last proof that we're going to do today. So, take a second, see what you can come up with. Try and do this proof on your own. Let's see what we can actually do by ourselves. Now, if you get stuck, press play for a little bit and get a couple hints. Try and finish this proof up on your own. That way we know whether or not you have a really good idea of what's going on here. Okay, so I started off with those givens. I have that K is the midpoint of MJ, G is the midpoint of FH. Angle GHJ is going to be congruent to angle KJH. Let's go ahead and let's put in that marking. So here we go. GHJ, KJH, and FH, which is this big long segment right here, is going to be congruent to MJ, this big long segment here. Now, right off the bat here, I think I know what my overlapping triangles are. So I'm going to take them and pull them apart. So here's one triangle with vertices G, H, and J. I'm going to put my marking down here at angle GHJ. My other one, here we go, draw this out on the side. Not pretty, but it's functional. We have K, J, and H. Again, we know that angle is going to be right here at angle J. Now, what I see here is I see that we have reflexive. They're sharing that full segment HJ. I'm going to say HJ is congruent to HJ. The reason is going to be reflexive. It's a full side of both triangles. I'm going to put in my markings here. And let's put in my markings on my original picture. Now we need another side. Well, as soon as I saw this midpoint pop up twice, we had midpoint, which is a keyword, midpoint, and I looked at what it was the midpoints of. My brain automatically took me to multiplication or division. I got keywords about those big segments, and those big segments themselves are congruent, which means all 4 little segments are going to be congruent. What's going to be most helpful for us? We're going to say that GH is congruent to KJ. The reason? Division. I'm going to put in my markings. Alright, there we go. Now, I'm going to look at my pulled apart triangles because my other ones look kind of crazy. What I notice here is I have enough information for me to say my triangles are congruent. I'm going to say triangle GHJ is congruent to triangle KJH. The reason? Side angle side. 2 sides in that smashed angle. Now, trying to prove that GJ is congruent to HK. Perfect. Those are sides of my triangles. GJ is congruent to HK, CTC. Beautiful. Easy peasy lemon squeezy, right? Not so much. Now, again, a helpful hint that I always use is when I see those overlapping triangles and I try and draw on my diagram, I do really struggle trying to put meaningful tick marks on. I always take those drawings and I put them out to the outside here. That's something that I always do. I find it helpful and beneficial for me, who is more of a visual learner. Alright, next we got homework answers. Alright, so for the answers for the homework, we had 2 through 12, the evens. Some of these proofs are kind of difficult, I'm not going to lie to you. So take your time, take a little sneak peek at them, see what you got. If we have questions, we're going to do an exploratory as soon as we get into class on this. But beyond that, I want you to come with some really good questions for me, some places where you're getting stuck. So let me know, and I'm here to help. Have a good one.